So we're going to spend the rest of the school year talking about something called factoring, and I've been mentioning it here and there, this triad. Basically, the idea of factoring is we're trying to find the factors that multiply to get something. If we were to factor a number like, say, 32, when we factored the 32, we made a factor tree, and we were asking ourselves, what do we multiply together to get 32? So when we're factoring a number, it's pretty straightforward. When we factor an expression like this, we're trying to figure out what two things can we multiply together to get this expression. And so the result, the answer that we got, ended up being the GCF of those terms times what was left after we got rid of that GCF from those terms. So we use this area model to factor this expression. And the idea is the same as when we use a factor tree to factor a number. It's just a little bit more complicated because we have numbers and variables in multiple terms that we're factoring. Okay. This idea of factoring we're going to use in a few different ways, but what we're doing today is what's called factoring using the GCF. So if you look at this problem that we did in the opener, on the front of our opener, on the first page, we found the GCF of these two terms. And then we use that GCF as one of the factors, one of the numbers that we're multiplying. And then we figured out what was the other thing we would have to multiply by so that if I were to distribute this, I would get this as my answer. So what we're doing here, factoring with the GCF, is the opposite of the distributive property. Rather than multiplying this times both of the terms in the parentheses to get this, I'm going backwards and figuring out what two things could I multiply to get this. I'll tell you right now, you already know everything you need to know to do this. We actually did all of the steps for these types of problems in the opener today. We just did it as two separate problems. We found the GCF and then we factored it using the GCF. We're just going to put those things together today. The other thing we're going to ask you to do, though, is draw your own area model. So we'll get into that. So we're going to factor this using the GCF. Anybody recognize this problem? That was in the opener. That was the first problem in the opener, right? So we've already found the GCF of this one. Let's go ahead and do that again together. While we're going through this, one thing I want you to keep in mind, since we're going to write an expression, more specifically a multiplication problem that's equal to this, we're going to put an equal sign here and put our answer over here eventually. So I'm going to keep this space clear so that I have somewhere to write my answer. All right, so underneath this, what's the first thing we're going to do to find the GCF?
Factor tree.
Factor tree. I know we just did this one, so let's go through it kind of quickly here. We get 2 times 3 there, we get 2 times 4, and then 2 times 2. So then we write our prime factorizations. So 6 is 2 times 3. 8 is 2 times 2 times 2. What do they have in common?
2.
2. So we'll write GCF equals what?
2.
2. And then how about the variable part? How many A's do they have in common?
1.
1. How many B's do they have in common? None. Now, this is our GCF here, but that's not our final answer. So notice that I circled it instead of boxing it. I'm going to use that GCF to help me with the next part. All right, the next thing we're going to do is we're going to draw an area model. Now, we did this a couple weeks ago when we drew area models. If we have two terms in our expression, how many boxes are we going to have in our area model? 2, right? So we're going to draw an area model here, and we want it to be 2 boxes, 1 box tall, and 2 boxes wide. So you should have an area model that looks something like that. We're not going to grade you on your artistic ability. It's a pretty ugly rectangle right there, but you get the idea, right? Now, where do you think that 2A is going to go? What do you think that's going to represent in this picture here? It's not the area, it's the height. So this GCF here, the GCF is always going to be the height of the rectangle. All right, so the 2A, that is the height of this rectangle. What do you think the areas are going to be of those two rectangles? The 6AB will be the area of one of them. And?
8A squared.
Close.
2A.
Negative 8A squared. Don't forget that negative on there. It is important. All right, so the GCF is going to be our height. The areas are going to be each of the terms in the original problem. And now we just finished the area model. All right, so this 2a is the height here, so I can label that in both of them. This is going to be 2a times something, and this is going to be 2a times something. And those somethings are going to be the widths of those rectangles. What do I multiply by 2a here to get 6ab? Okay, so the number part's going to be 3, because 2 times 3 is 6. We already have the a that we need in our area, but what are we missing? We're missing the b, so we'll throw that on there and multiply by b also, so that when we multiply 2a times 3b, we get 6ab. All right, over here, what do we multiply by 2 to get negative 8? Negative 4. And what do I multiply by a to get a squared? A, right? So I have one a, but I need 2 of them, so I'm going to multiply by 1 more. So this 3b and this negative 4a, those are going to become my, starts with a W, widths. So I can label those up top, 3b here, negative 4a here, and my area model is complete. All right, we did that all by ourselves. We didn't give you the boxes. We didn't tell you what the height was going to be. You figured that out on your own by finding the GCF. And now I can use this to write my answer to this. Okay, so I'm taking this expression here and I'm factoring it. So what 2 things can I multiply together to get this? I'll give you a hint. It's going to come from our picture here. What 2 things do we multiply together to get this as an area? How do we get area? Area is height times width. What's the height of this rectangle?
2A.
2a. So that's going to be my first factor in my answer. What's the width?
3B.
Well, the 3b is the width of this one, and the negative 4a is the width of this one. Now, be careful here. What order do we want to write these? Which one should come first?
A. 4.
The a, right? So what's the power on this one?
B.
1. What's the power on this one? 1. Powers are the same, so if the powers are the same, we need to use alphabetical order. And in alphabetical order, which one comes first? The a does. So in parentheses, we're multiplying by negative 4a plus 3b. So let's just review what we did here real quick. We'll go through the steps that we followed here. First thing we did is we did factor trees, prime factorizations, and found the, what is this? GCF, right? Then we used the GCF as the what in this model? The height. So we're going to say that this GCF is the height. The 2 terms that we started with are the areas. And remember, we're trying to figure out what we multiply together to get 6ab minus 8a squared. So we multiply the height times the width. So we use this area model to figure out what the width is and write our answer. Who can tell me why we wrote the width in parentheses here? So if we didn't have these parentheses here, we would have the height times part of the width, but not the whole width. So this right here, this parentheses, this is the width of the whole thing. It's what we get when we add both of these together. All right, now we didn't actually add them together, but it's subtraction because one of them's negative, and we did flip the order because we have to put them in alphabetical order in this case, but we need to combine those 2 widths together to get the entire width. And so what we're doing here is we're multiplying the height times the width. Now, this is my final answer right here, so what should I do with it? Put a box around it. So like we've been doing recently, notice that we have the problem here, and we put an equal sign and wrote the answer right next to it. And all of our work is underneath showing how we got that. Before we move on to the next example, let's fill in the blanks here. First step, what was the first thing we did? We did factor trees, wrote the prime factorization, figured out what they had in common, all of that to find the GCF. So the first step is to determine the GCF of all the terms in the expression. Once we did that, we drew an area model. And how many boxes did we draw in that area model?
2.
2, right? Why did we draw 2? Because there were 2 terms in the expression, right? So when we draw the area model, we're going to draw one rectangle for each term. we had two rectangles in that area model because there were two terms. So we're going to draw one rectangle for each term in the expression that we're factoring. All right, then where did we put the GCF? We put it in there as the height, right? So we put it off to the side. So we're going to say put the GCF on the height of the rectangles. And then once we did that, we completed the area model, right? So we'll just fill this in with the, we'll just say model. We'll complete the model. And then once we finish that model, we use the model to write our answer. Specifically, when we wrote our answer, we had the height times the width, because the problem that was given to us is the area of the rectangles. All right, so let's factor this using the GCF. All right, so remember, the first thing we're going to do is find the GCF. So write down the problem, start your factor trees, write your prime factorizations, figure out what they have in common, see how much of that you can do on your own. So we'll start with factor trees. And then prime factorizations. And then we look for what they have in common. What do they have in common here? Somebody help me out. Looks like they've all got a 3. Okay, what else? That's it? How about another 3? And then another 3? No, because the first one doesn't have another 3. All right, so then we write GCF equals, what's 3 times 3? 9. Okay, how many C's do they have in common? 2. So we'll have C squared. How many D's do they have in common? 2. So it's going to be D squared. And so that's your GCF. We're going to use that as the what?
Height.
As the height. Okay. So now we're going to draw our area model. And how many rectangles should be in my area model?
3.
Why 3?
Because there's 3 numbers.
Yeah, there's 3 terms in the problem, right? So I'm going to make 3 rectangles. I'm going to make it as big as I have space for here because I'm going to need some space to write this stuff. And then when I label this, what's the height of this going to be?
9c squared 2.
9c squared d squared. And I can also label that inside the rectangles. It doesn't really matter at what point we do this, but that's going to be the height, and we need to figure out what the width is. And then I'm going to label that in all of these here. So we have 9c squared d squared times something in every one of these. And then what else do I know about these rectangles? We know the areas and can write those in. So we're going to have 45 c to the 4th d squared, negative 27 c cubed d cubed, and 54 c squared d to the 6th. All right, so what do I multiply by 9 to get 45? 5. And how many c's do I need still? I need 2 of them, right? So it's going to be c squared because I have 2, but I need 4. How many d's do I need? 0. Okay, move into the next one. What do I multiply by 9 to get negative 27? How about negative 3? How many c's do I need? 1. How many d's do I need? 1. Okay, so we get negative 3 cd. And then the last one, what do I multiply by 9 to get 54? 6. How many c's do I need? How many d's do I need? 4. I have 2 and I need 6, so I need 4 more. All right, so those are my widths. Let's label those real quick. 5c squared, 3CD, that's a negative, and then 6D squared. Last thing we need to do is write the answer. Unfortunately here I don't have enough room to write my answer right next to it, so I'm going to go underneath. What's the answer going to be? What's the first part of it going to be? It's going to be the height, right? I'm going to get rid of my factor trees here. I know you guys can't do that, but you should have enough room on your paper, hopefully, to write your answer. So I'm going to write equals underneath, and we're going to start with the height, 9c squared d squared. All right, now we need to write these terms in order. Which power is the biggest? And I see a mistake I made here. This should be d to the fourth, right? Which one's got the biggest power? That's 6d to the fourth. So we're going to write that one first. All right, the other two have the same power, don't they? They're both second power. So which one comes first? C squared, cc, or cd? C squared. So plus 5c squared minus 3cd.